This tutorial explains how to solve a nonlinear equation. These equations appear quite often in open channel flow, especially if we are trying to find critical depth. It results in a equation, a nonlinear equation with sixth power of the depth. So in order to solve it, um, we have to either use trial and error method, or we can use design curves. But MATLAB provides some quick and easy ways to solve these kind of nonlinear equations. So if we are trying to, if we use Froude's number to calculate critical depth, it gives us a times square root of d um, equals to uh, a quantity which depends upon the discharge, the slope of the channel, the alpha of the channel. And if we know all of these terms, we can find a square root d and then solve it for depth for any arbitrary cross section. So suppose if it was a trapezoid, then we know what a and d for trapezoid are. If we plug those in, we will have a equation in y that needs to be solved for y. So here's an example from um, a website where the values of the area and hydraulic depth in terms of y are given. So a square root d is computed, and in this case they square it on both sides so that the square root is gone. But at the end, you still get an equation in y. So assuming some values for the variables, when it is plugged in, we get an equation in y that needs to be solved to find y. Now in this case they use a trial and error method, and they find that the value lies between 0.65 and 0.7. But we will use MATLAB, and in MATLAB we will program this function and then ask MATLAB to solve it for us. So the way we do it, we define this full function. We take 3.66 onto the other side of the equation, so it becomes a function is equal to 0. So this is how we do it. F is equal to an at symbol, basically defines the variable that we will be using in the equation, and then we write the equation. So we have 3 plus y cubed and y cubed, and over 3 plus 2y minus 3.66 is equal to 0. So 3 plus y cubed times y cubed divided by 3 plus 2 into y, and that we subtract 3.67 out of it. I've rounded 2 digits, and this gives us the equation. Now we can quickly do an easy plot and see what this function's plot looks like, and we can see that it has a 0 value. It crosses here 0 value, and there is a discontinuity close to minus 1 point, between minus 1 and minus 2. So we are interested in this point where it crosses the 0 axis. So there's it can be done using the plot, but we can use the function called f0 and give it the value of the function, but then we also have to initialize the value. So let's say we guess an initial value of 0, and we run f0, and this gives us 0.68. So the critical depth for this function is 0.68. Now if we look at their solution, it's between 0.65 and 0.7. And what we have done is we have solved this equation for y, or in other words, we have looked at we have found the location where this curve f of x, or in this case f of y, crosses the x-axis. So this is how we can find critical depth. And there are several other applications in open channel where we may need to solve a nonlinear equation, and this method can be used for this purpose.